Here's the finished Husqvarna leaf blaster conversion. I took out the original battery completely. This was a 270 watt hour battery, and I replaced it with a 2070 watt hour battery, so quite a bit larger. I also replaced all of the internal electronics in it because they actually use a trapezoidal drive strategy, which is quite inefficient. Here I have a screen capture of just one of the phases, or really from, phase 1 to phase 2, because there's no center tap. The white trace here, well, we'll look at the green trace first. This is what I'm using now, which is a field-oriented control strategy. That's what the new electronics allow me to do. This is a much more efficient drive algorithm because you basically drive it to where the D current vector is 0. The D current vector is basically when you're not actually adding any rotational torque by adding input electricity. For example, when the north magnet is directly axial linked to the north magnet on the rotor, for example. Don't worry about the details if that's not immediately obvious. What they're using on their stock controllers, this reference signal I have, this is just a standard trapezoidal drive. The walking off that you're seeing here is just how it's controlling the duty cycle, when you're pulling the trigger halfway or all the way. So yeah, they're just using a standard trap drive, which I think it's quite mind-boggling to me because it's a very inefficient algorithm. This algorithm here, you're talking from going from increasing from the 80% efficiency as far as electrons in to rotational torque out to high 90% with this. Now this is a much more challenging algorithm mathematically, but this is a solved problem. It's open source. The VESC controller suite, VESC, does this all for you, and you just have to set up some parameters. And anyway, quite good. I'm actually quite embarrassed for Husqvarna for not using a better control strategy because they're giving up a lot of efficiency. They could increase their battery time by 20–30%, and of course they could increase the amount of energy you're able to put in the motor without the motor heating up, because all that inefficiency is ultimately turned into heat inside the motor windings. So I'm running this motor at about 800 watts. I'm not using these buttons at all. They don't even do anything anymore. I could, chose not to, doesn't matter. So I basically run it like this, and you can just pull that whenever you want. This is by far the best leaf blower I've ever used. Even in its stock configuration with this and the battery, my main complaint was just time. The time sucks on this, whereas this is hours. So at the 800 watts peak, when I pull the trigger all the way down, that's 2 hours of runtime. If you just held it down straight for 2 hours, that's what this would last. And of course, if you modulate that trigger at all, then you could get 3–4 hours. Probably longer than you want to be leaf blowing. So anyway, yeah, it's attached to a backpack. It is fused. You don't see the fuse there. It's on the bottom. Don't worry, it's fused. Yeah, so that's it. And the last thing I wanted to point out is this leaf blower has a USB port. So I basically have a USB debug in there so that I can go in and change the firmware parameters on the VESC controller, which I figure I'll do now just to show you how it works. Let me plug this cable in. There. So you plug that extension in there, and then come over here and grab your laptop and log in. So here's the VESC tool. This is an open source tool, and I'm just going to plug that guy in, and I'm going to come over to disconnect, and then let's see if we can connect. Yeah, I think we've connected. Let's see. We're going to read the motor configuration, and then we're also going to read all of the user settings there. And so here's where we set, the voltage limits, the RPM limits, etc. And they actually have this real-time data app here, and I think it's this. Yeah, here you go. So you can actually see the way this tool responds. Now I'm inside right now, and I think if I blow this at full speed, it's probably gonna, every cobweb in the world up, but let's see what we can do. We'll just aim it at the ceiling here. So you can see that I have a current limited to 50 amps on the output phases, which is what we're doing there. So we only hit like 35% duty cycle as far as what this internal electronic controller can do. But yeah, there's so much data you can do with this. It's really, really awesome. This is a really, really cool project. I started in, I think, 2017 or so. But it'll even tell me here that I've used 3.9 amp hours. I went out, 4 amp hours at this point. I went outside and just blew off like a 700-foot trail. I think my battery might have died. Yeah, well, my battery is completely dead on my laptop, so whoops. But anyway, yeah, I used 4 amp hours blowing off, maybe 800 feet of trail in my driveway. That's 47 amp hours, so, anyway, that is this long project. I spent a little more time, as I tend to do on projects, than I intended to on this project. But it is finished now. It's totally mobile. It's even got a quick disconnect, so if you pull on this cord quickly, because it's Anderson's, they'll come off. And I'm using 10-gauge wire there. I think it turned out pretty clean. There's no wood, there's no duct tape. That's always a sign of a good project. So thanks for watching.